Hello everyone, welcome to Azure IoT Fundamentals. My name is Khalid Jimni. I'm a software engineer and I specialize in building IoT solutions. During this course, I will walk you through the basics of Azure IoT and what we have available as a platform as a service in Azure IoT. Then we will take it into hands-on lab experience with creating components from the portal and linking them to projects on Visual Studio, and we will build solutions connected to Azure IoT. Let's start by speaking about the waves of innovations that we are facing. It all started with the cloud. It's globally available. Cloud computing completely changed everything in this world, and especially with our world as software engineers. Then we came to speak about IoT after speaking with the cloud. We came to speak about connected devices and connected things that connect to the cloud and to connect to an IP address, and then this took us to using these devices in real case scenarios in our lives. And this thing allowed us to speak also about the edge. And we will speak in this course about how to use AI in Azure IoT. Let's speak now about the Internet of Things opportunity that we are facing nowadays. We are talking here about 70% value enabled by IoT from business to business scenarios. We are expecting to have around 80 billion connected things by the year 2025. And on the same year, we are also expecting to have 180 zettabytes of digital data. Not to mention that we are speaking here about a lot of money, which will be around $400 billion around the year 2020. Let's take it now to real case innovations at work using IoT, and here we can mention a lot of examples. We can start by talking about the connected airplanes and airports that are making too many lives easier by extracting too much data from the airplanes and airports in order to make it a better service. We are also going in a new world with connected cars that will make the life of the drivers and everyone using the cars easier by extracting too many data from the car and using it in a mobile application or in a web application to help manage your car using IoT. Not to mention also that we are speaking here about smart buildings, smart workspaces, and putting sensors all over the place in the workspace in order to make it a better place to work in and to increase the productivity of employees gathering too much data. We are also going into shopping with real IoT use cases and traffic systems, trucks, weather systems that were the basics of IoT in order to get sensors and predict the weather, and too many other things like factories and predictive maintenance in factories with remote monitoring solutions that we will talk about in the next slides. Let's go deeper now and define what is really IoT to us. So, as a simple definition, because everyone will give its own definition to IoT, we can bring down IoT to three main parts, which are things, insights, and action. Let's start with a simple view of an IoT solution. For Azure IoT, any IoT solution starts with three components, which are things, insights, and actions. For things, and not just devices, we also include industrial PCs, gateways, and everything collecting data. For insights, we use insights to find real-time insights, historical insights, and driving improvement in your connected things. And finally, actions, which are very important from the economy perspective, because that's where the money comes in any IoT solutions and any IoT scenario for any IoT product. Yet, IoT projects are still complex because everyone will say security is a challenge for IoT solutions and they are time-consuming to get started. But here we will speak also about how secure IoT is and how secure your devices and your things can be using Azure IoT, and how secure your data will be while it's coming out of things and devices connected now to the cloud. And we will speak also about pre-configured solutions that are ready from few clicks to be ready to use. So you will have a ready solution for IoT that you can use and customize depending on your need. And we will explore also how it is able to scale with IoT solutions from Azure IoT, and it will be no longer a challenge to scale. Let's take it now into the industry's most comprehensive portfolio for Azure IoT and talk about PaaS and SaaS solutions. In Platform as a Service, we have Azure IoT Suite, which is a pre-configured solutions for common IoT scenarios. And during this course, we will take it into a deep dive into Azure IoT Suite and see how we can create a pre-configured solution in a matter of clicks, and then we can configure it depending on our need. Also, we have a SaaS solution, which is Microsoft IoT Central, which is ready to be used as a SaaS solution. Also, we can speak about technologies in platform as a service. In device support, we have multi choices for Azure IoT device SDKs, certified devices, security program for Azure IoT and Windows 10 IoT. And then we have components on the cloud that we will create one by one during this course, like Azure IoT Hub and the IoT Hub device provisioning service. And we will work also with Azure IoT Edge. We will talk also and take it into a deep dive about data and analytics and see how we can use Azure Stream Analytics to treat data and Azure Machine Learning, for example, and how to visualize data with Azure websites or Azure Logic apps or Microsoft Flow, or how to send notification from an IoT solution using notification apps. So, to conclude, we can speak about Azure IoT as secure, fast, open, and scalable because it's providing security in an end-to-end way, fast solution that you can start building it in minutes with pre-configured solutions, open because we can connect anything to Azure IoT, and scalable because we can grow effortlessly using the components of Azure IoT. We'll continue in this course is discovering together what's Azure IoT, and we will take it into Azure IoT Hub and see how we can work with these components on the cloud to connect them to a real device. Thank you for watching this video. IoT Hub is one of the most important and common component on all the IoT projects. We will see how we will establish a bi-directional communication between cloud to device and device to cloud messages, and we will see how to send this telemetry from a device to the cloud and from the cloud to a device in a secure way. And then we will talk about provisioning and how we can have the device management on IoT Hub.
So for Azure IoT Hub, we can have the bidirectional communication for millions of devices, and we can send the cloud to device messages, or we can receive the device to cloud messages in developing with multi-languages. So we can develop in any language that we can feel comfortable using the open source SDK we have and using the protocol that we are most comfortable with, either HTTPS, AMQP, or MQTT, and we can receive commands on the cloud and have device management, as you will see it later on when we start on the demo. We can have enterprise scale integration, billions of messages, depending on you create the IoT Hub on S1, S2, or S3, and we will see in the video how we will do it. We can upload files, we can check what is happening on our IoT Hub, and we can have an end-to-end security per device certificate using the X509 support, the TLS security, and we will go with shared access policies, how to connect to the IoT Hub, and we will see how to do it now when we start working from the portal. So I am logged now into my Azure subscription, and I will be able to create an IoT Hub. In order to do that, I will click on Create a Resource, type in IoT Hub and look for it. Choose IoT Hub here and then click Create. Once I click Create, I will have this page shown to choose which subscription I'm creating my Azure IoT Hub, the resource group I will attach it in. So if I'm creating a new resource group, I will have to type its name here. In my case, I will use an existing resource group that I have on my subscription. We have to carefully choose the region on which region we will create the IoT Hub, and then we will give it a name as my course IoT Hub. And then I will click Next, Size and Scale. Here we will choose the pricing and scale for our IoT hub. If it's S1, S2, S3, basic, or on the free tier, I will choose S1 here, and we will talk about the differences in the next videos of the tutorials. And here we'll go to review and create. How much messages per day will we be able to send on this IoT hub, the cost per month that we can have, and all the details. So it's on this subscription, on this resource group, and this is the region, this is the name of my IoT hub. It's on S1, it's one, it has the number of S1 IoT hub units is one, and we can send until up to 400k messages per day. So now all I have to do is to click create and wait for Azure to deploy my IoT hub into the resource group I have, and this will be shown here. So now the resource is created, and you can see it's deployed on the resource group, and I can click here on go to resource to go check the IoT hub that I've just created on this Azure subscription. Here, so we can see an overview of what is happening on our IoT hub on or the details of our IoT hub. So we have the resource group, we have the status, it's active, the location is West US, subscription, this is my subscription ID, it will be hidden on the video, and we have here the host name, the pricing, and scaling tier S1, which we discussed, and here we can see other related documents like DPS, with device provisioning service, that we will talk about in the next videos. We can check activity log, we can check tags, we can check events, we can go through everything on our IoT hub. So for example, if there's data happening on our IoT hub, we can filter and have on the time span last hour, last 6 hours, and see the data that is happening already. And we can also check the events or create and work with an event grid or Azure function or a logic app that we will do in the next videos when we go forward with this course. What matters us at this stage is this part. It's settings, shared access policies. So if we can click here and go to shared access policies, we can find here the policy and the permissions that we have. So we have IoT Hub owner, which has the permissions of registry, write, service connect, device connect, service, device, registry read, and write. And all of these, we can work with them in while building our IoT solutions. And the one that we will work with is IoT Hub owner. And here it will show this window as showing these permissions, write, connect, and device, service connect, and device connect. And what's the most important part, it's the shared access keys that will go into Visual Studio when we start coding our client application connected to the IoT hub. So we have a primary key, secondary key, connection string, primary key, and connection string. Secondary key will go deeper when we use these keys and talk about the differences. For now, we will using this connection string as primary key, and we will click here just to copy it. So once copied, we can keep it on a different document or whatever you want to keep it, and we will go to the next step, which is going into Visual Studio to connect this IoT hub with an application.
So I've created a console application on Visual Studio 2017, and we will connect our IoT hub that we created from the portal to this application. And in order to do that, we need to go back to our IoT hub on the portal, go here to shared access policies, and click on IoT hub owner as we saw, and then copy this connection string primary key. We will go back to Visual Studio, and then we need to add our connection string here at this line of the code. And there it is, it's added. Now for the rest of the code, it's commented. Now we can see that we have a static service client that I call it service client, and in the main method I'm just launching the new program that I have in this console application and creating this instance as of this line of code with the service client. Now the thing that we should consider also is this public program method, which is using an instance of the device client, and then we are sending the event to start sending the events to the IoT hub from this console application. And this method right here is for sending the event to the IoT hub, and this one is just to we are calling this method to execute it, and then we can see the code here, and this is a method that we will send a static message that we will be sending from this console application to the IoT Hub once the application is launched. And this is a message that we can send, for example, and then we can just make this instance, and then this is your device ID that you need to have in your application and that you need to have in Device Explorer in order to be able to send this message to the IoT Hub as a device to cloud message. And then this method is responsible to receive the message on the IoT Hub. So it's an asynchronous method, and it just receives commands as it's written, and we will be showing a small message, device waiting for IoT Hub command, and then we will have a string which is message data, which we have our message, and then while true we will work on the receive message and show it and receive it, and then if the receive message is not null, so we will be showing it as this line of code console write line, and then the message received and all these parameters that you can check. So this is an easy console application that explores a device to cloud message, that we are sending this message from the device to the IoT Hub. And in order to do that, we will be using in the next step Device Explorer before we can run anything on the application. So I launched here Device Explorer Twin that you can install online, and you can see here that I should change the IoT Hub connection string from here. So I should paste the connection string that we copied from the portal here, and then click update, and you can see it's updated already. And then we can go to messages to devices, and then we can see here our IoT Hub, and here we can see that we have a drop-down list for device IDs, which means we need to have a device ID. So let's go and create a device ID. So here I will do click on create, and then on device ID I will just type my device and then click create. And then there's the ID, my device, and then there is the primary key that I have. And we can see it now on Device Explorer Twin created. And if we want to send messages to device, we can see that my device is now added here. We should make sure that it is the same ID as I have it here on Visual Studio. And then we can have this application running, and we can see the messages being sent from our device, from Device Explorer Twin to the IoT Hub on Azure. So we will go now and build the solution and see the console application running with our device ID, and you can see that device waiting for IoT Hub, and there you go. The message is received because we already added here the IoT Hub, and we have device ID, and then I can update, for example, a message here saying hello, and then I can send it. And you can see here on the console application, I received the message on the IoT Hub, which is the message I sent from the Device Explorer Twin. And if we can go back to the portal now, and then we can refresh on our IoT Hub, and then we can see that we already sending messages to our IoT Hub, and it's shown on the portal for the number of messages that we can get on the IoT Hub here at the beginning. So if we go to overview, and then we can see here that we have IoT Hub usage, we have the messages that we received, IoT devices, my IoT device that we added already from Device Explorer, and then we sent it to the IoT Hub. So this is it for this video. We will continue working with IoT Hub in the next videos. Thank you for your time. DPS, or Device Provisioning Service, is a way to provision and register devices on the cloud with a zero-touch way. It's secure and it's scalable, and it offers a lot of options for security like X509, TPM. We will go through that in the course. But for now, let's keep the idea that DPS will provision up to 1 million devices in a zero-touch way, which will increase security and which will reduce the manual errors that we can have while registering or provisioning the devices.
Let's take a look at an example for an IoT architecture with device provisioning service. So between the device and the IoT hub, while we are sending the telemetry data, provisioning will happen between those two parts in order to have the device IDs provisioned and registered in an automatic way. Later on, we can continue on the portal with other components like stream analytics and storing the data like we see on the architecture and using our devices that we already registered and provisioning using DPS.
So we will create now our device provisioning service from the portal, and in order to do that, we will log in into our Azure subscription, click on create a resource, and then type in the search IoT Hub device provisioning service, and you can see it here. So we can click on it, and then we can click on create in order to launch the creation of our device provisioning service. So we should give it a name. I will name it course DPS. I will choose the subscription, and for the resource group I can either create a new resource group as we saw in the former videos, or choose an existing resource group. In this case I will choose an existing resource group which I have here on my subscription, and then for the location I need to choose on which location I can create the DPS. I will put on West US and then click create. Once the resource is created, we can see on the notification tab from the portal that the deployment is succeeded and it's already added to the resource group. So we can click on go to resource, and we can check here the resource details such as resource group, the status of our DPS, location, the service endpoint, our ID scope, which we will use later on while coding in the applications. We can check also our activity log to check everything related to our DPS with filters that we can apply. Here we can see the properties of our DPS, just like we summarized it when we started out for the subscription ID and resource group and all the other details. Logs is one of the most important also features. For example, I can add a log here that I can call delete, and if I can open this log type, we can see that we have two options. First one is read only, so I can make my DPS with this log as a read-only resource, or I can choose the second one, which is delete. So while clicking on delete, I can add here a note which is keep data. So what will this log do is that even if I remove my DPS from the portal and from this subscription, if we lose it, for example, or if it gets deleted after an error, we can still be able to keep the data or keep the things that we did provision with our DPS. So I can click OK here and we can have the log added. We can check here also the shared access policies, which we will use later on also while coding, and just here we can see that the permissions, that device connect, enrollment, right, service configuration. Here it's one of the most important things for IoT Hub, linked IoT Hub. So as we presented earlier, we can link our DPS to one or multiple IoT hubs, and later on to have device IDs and to have the provisioning happening. So this is where we can choose the linked IoT hub. Certificates is for certificates that we can add and attach our own certificate. For example, if I can add here the certificate, as we can see, I can browse and go get it from my local machine, the certificate that I added or that I generated from PowerShell or whatever you do to generate the certificate. Here we can check the managed enrollments that we have, and we will work here more later on in the videos when we go forward with the course and work with, especially with IoT Edge, managing a location policy and what we want to do exactly. So this is in general an overview of what we create when we choose to create device provisioning service from the portal. Next steps is to see how we can link an IoT hub to the DPS. So let's see now how we can link an IoT hub to our device provisioning service. So we will go to this tab here, linked IoT hubs from our DPS, and then we will click this button, add, and then I can choose either I'm creating this, either I'm adding an IoT hub that belongs to the same subscription or to another subscription. In our case here, I will have the same subscription, and then I can choose the IoT hub, which is this one that we created in the past videos, and then for the access policies, I will choose IoT Hub owner, and then on the portal I can see here the host name, the status of our IoT Hub, which is active, pricing tier S1 and its location that we went through in the past videos while creating the IoT Hub. And then I will click just save, and we will wait for a small notification saying that this IoT Hub has been linked to the device provisioning service, and then we can take it forward and move on with our uh, device provisioning service.
Next, we need to clone the IoT SDK C on our laptop by typing this command using the command prompt. And it will take some while, so please be patient while it installs and wait for it to show that it's already finished in order to keep moving with working with device provisioning service.
Start from the portal by copying the ID scope from your DPS, and then on the CMD file type in .NET Run and paste your ID scope. After that, we will have the registration ID and the endorsement key shown on the CMD prompt. After this, we can go back to the portal and go to Manage Mechanism, change the mechanism to TPM, and then we need our endorsement key and our registration ID that we will copy and paste from the CMD file to the portal. After that, we can assign an IoT hub to our DPS, and finally, we will click Save. In the next part, we will have some coding to do on Visual Studio in order to finish this, but we can check here after pressing enter on the CMD file that a new device has been created if we go to IoT devices from the portal, and we will find it. Now go back to the portal and go to Shared Access Policies in your DPS and click on your device, and then we will copy as usual the primary connection string from the portal and we will use it in our code.
Let's start now from Visual Studio. I will go to File, New Project, and then I will create a simple console application that I will call TPM sample, for example, and then just click OK in order to launch this console application so we can start coding and using our device provisioning service with the connection string that we've already copied from the portal. First thing that we need to do is to add NuGets for device provisioning service. So we will go and right click on the solution, manage NuGet and packages, and then go look under browse for our special NuGets. Let's just type device provisioning service, and we will find the NuGet that we need shown on Visual Studio, which is the second one here. So Microsoft.azure.devices.provisioning.servers. So we need just to check it and then click install for our solution on Visual Studio. Later on, we can start working with DPS officially on this console application. We can see the output from Visual Studio to tell us that it already installed the NuGets. We need to accept some changes and move forward with it. Please be patient for it so it can install all what it needs so we can move forward and continue working with DPS. And this is the license that we need to accept in order to start working with coding for this small console application. We can see here now it's already done and already finished. We will need to declare a few things. So let's start with the connection string, which goes as private static string, and we will just name it provisioning service connection string, or provisioning, let me say, connection string. Okay, it will be a connection string that we will copy from the portal. The second one will be our registration ID, so we would need to declare the same thing on a new line. So it goes as private const and string, and we'll call it registration ID. It will be also a string, so I need to do this. And the third one that we will need, sorry, it will be also as a private constant, also as a string, which is our endorsement key. So I will just call it endorsement key. and then we will add a method, and you can find this source code on the GitHub with all the details with connection string. Maybe it will be deleted. And then there's two methods, the one which will create a new individual enrollment configuration, which is creating a new instance of attestation and then having registration ID as a parameter. And then the second one is creating the individual enrollment, which is on different regions, and you can also later on add on the main this line of code to run sample and to start working with and to see how we will work with DPS. We will need to build the solution and then click on run. Once it's running, we will have a new enrollment created, registered, and we can see it on the portal, how it's automatically generated on Azure.
So before talking about Azure IoT Edge, we need to understand the difference between intelligence in the edge and intelligence in the cloud and how they complement each other. So let's start with intelligence in the cloud. So for everything related to the cloud, we will have remote monitoring and management. Will be merging remote data from multiple IoT devices. We'll have infinite compute and storage to train machine learning and other advanced artificial intelligence tools. On the other side, when we talk about intelligence on the edge, we have low latency tight control loops that require near real-time response. We have protocol translation and data normalization, and we have privacy of data and protections of IP. Edge runtime provides fundamental services such as management, connectivity, and security for devices otherwise isolated from the internet. So these devices, which are isolated from internet, speaking non-internet compatible protocols, will be connected through Azure IoT Edge, which is our gateway to the cloud. And also we can do multiplexing, connecting many devices into the IoT Edge, and most importantly, store and forward offline. So if the device is not connected to the internet, IoT Edge will store the data that it received from the devices, and then it will forward them the next time they are online. Let's speak about the modules. So Edge runtime manages modules. So modules add capabilities to the runtime, and each module performs an action. So chain of modules can be thought of as data processing pipeline or solving an end-to-end scenario. Models are Docker containers, and here we have the choice either to go with Docker for Linux or Docker for Windows. And custom models can be written in the language of your choice. So we can write this model as in C# or in Java or in Python or whatever we want to write this module. Let's speak now about a scenario. So we will find insights in the cloud from a telemetry sent by a device that does not speak an internet-ready protocol. So this device is sending telemetry into Azure IoT Edge device, and we have a module published on our IoT Edge, which is protocol ingestion. So what it will do, it will translate this non-internet ready protocol coming and with the telemetry data in order to have a internet compatible protocol. So that's, for example, a module that we can publish on Azure IoT Edge, and then we can have another module for data formatting. So the data coming from these devices can be of any type. So we are able to filter this data and get only the fields of the data that we will use in order to progress with this data. So we can publish this another model on IoT Edge for data formatting, and then we can of course we are using the Azure IoT Edge runtime, and then we will send that telemetry, which is not internet compatible for protocols and which has a data which has been formatted depending on our need. We can send it later on to the cloud in order, for example, a machine learning model or have application insights or whatever we want to do. Let's see another concept, which is cloud offload. So modular architecture for cloud offload. We'll speak about Azure services, how they provide AI models. These models provide true edge analytics, so we can have the analytics of what's happening on IoT Edge, and we can see what's exactly happening with our telemetry and our data. And we offer an ecosystem for third-party edge services. Let's talk about another scenario, which is find insights locally from a telemetry data and only will be sending insights to the cloud. So we will be managing everything on the edge and then we'll send only the telemetry to the cloud. So we have our IoT Edge runtime as usual. We have the telemetry data coming from a device speaking in non-internet compatible protocols. So here we have three things published on the Azure IoT Edge. The first one is a model to ingest. The second one is to format the data. And then we have a machine learning model that will work on the telemetry. And then once that is all done, we can go with the insights on the cloud. So this is the other part that we spoke about with intelligence on the cloud. And the first part on the left, it's what we spoke about, which is intelligence on the edge. So how about cloud configurability and monitoring? So Runtime plus our IoT Hub provide full control of the device lifecycle. We can configure a workflow for this. We can target a device and we can deploy, monitor what we have. So let's see how it works. So we have the this scenario, find insights locally from telemetry data and only send insights to the cloud. So we have our device and we have our IoT Edge and our IoT Edge runtime installed and configured. So the device will be sending the telemetry data in order to progress, sending it to the Azure IoT Edge to three models, which are ingest, format, and machine learning. And then we will go to the IoT Hub on the cloud and we will go to the intelligence on the cloud. We'll move now to a demo and see we can configure and deploy Azure IoT Edge from the portal, and then we will work on publishing models and publishing machine learning as a model, or publishing Azure function as a machine as a module on the IoT Edge. So in order to start, before going to the portal, we will need to install the IoT Edge runtime on our laptop, on our work machine. So we will launch the command prompt and then we will type a small command in order to install. So it will be pip install space and dash u and then Azure IoT Edge runtime CTL and then hit enter. It will start installing and then we will have to wait for it in order to be installed on the laptop. And we can see now that it's successfully installing and happening. There you go. We are now, we did install the runtime on our machine. After installing the IoT Edge runtime, we will go back to our IoT Hub and we will need to work a bit from the portal in order to progress and have the IoT Edge. So from the menu on our IoT Hub, we need to go to automatic device management. We go to IoT Edge and here I can see that I have this plus icon, which is add an IoT Edge device. So I will click on it. I will add an IoT Edge device. So I will have it I will need to create it. So create a device ID. So I will call it my Edge, or let's call it something different to avoid problems. So I will call it my device 1, and then I will let Azure auto generate the keys for primary key, secondary keys, and hit save. So now I have a notification, create a device. It has been created successfully and I can see the device. I can click on it here and I can show, I can see my device ID, my primary key, secondary key, connection string, the primary key, which we will use, connection string, secondary key, and here we can see set modules that we will use later on in order to set modules on IoT Edge, manage child devices, regenerate keys if I want, and refresh. So I will copy this connection string that we will use and to go back to this CMD file, and there we will need to start the IoT Edge runtime, and that we will do it with a command. So let's go back to the command prompt, type in IoT Edge CTL setup -- and then connection string, and here I will paste the connection string. So I need this, and then I paste my connection string, and then I need double, and then dash dash no pass to say no password, and then hit enter. It's IoT Edge CTL start, and there you go. Let's go back now to the portal after we installed the runtime and we did start it. So we're back now to the Azure portal, to the IoT Edge device that we created. And as we saw earlier, we can see here that there's set modules on the menu. So I will click on set modules, and here I can see that I can publish modules from here into our IoT Edge. So I can have deployment modules added from here. And if I click on add, I will see that I can add an IoT Edge module, a custom one. I can add an Azure Stream Analytics module, and I can add an Azure Machine Learning module into my IoT Edge. In our case, I will add a custom IoT Edge module that has been developed before, and I will create it from this menu. So here we will need to fill in the IoT Edge custom modules, the name, the image URI, and we will talk about this. So in order to create it, I will just name it here temp sensor, and here I will point for the image URI to a Docker container image that is already created and developed. So that's the URL for my image, and then I need to click on save. And that's it. You see now I can have my modules. It's created already. It's running. I can see the details of my modules if I can click on it, so I can see the name, I can see the image URI I have, and if I want to make updates, restart policy. It's always desired status. It's running. So all good for my first module. And now we will move to how to create another module, but this time we will use Visual Studio Code. So the next part is done on Visual Studio Code. So you need to install Visual Studio Code on your laptop, and later on you can add the extensions for IoT for Visual Studio Code. So I added some code here in order to have this module work for IoT Edge, and this code is written in C#. You can write the model depending on the language that you want to, and this code can be either written in JavaScript or Python or whatever you want. So you'll find this source code on my GitHub, of course, and this sample is really simple. So we took the same data that we worked with before in order to have the telemetry data, and then deserialize it. And the goal of this is to send a message. So we are working here machine, ambient and time creator, temperature and pressure. This is the telemetry that we are getting, and here we can see that we are receiving and transferring a message with temperature above a defined temperature. So the goal of this method is to, when it receives a notification that the temperature of the machine is above the threshold temperature, it will send an alert, and there we are receiving the temperature here, for example, which is we are fixing the temperature here for 25, and then we can move forward. So we are deserializing with the telemetry data we are getting, which is JSON, and then we are continuing, and this is the definition of the expected schema for the body of the incoming messages. And then we can see that for each message we are filtering the message and adding a new property to the message to indicate it is an alert, and then we add the message type that it is an alert, and then we send the message with an asynchronous way with this output dot add async. So you can have the extensions for Visual Studio Code. So in order to see Azure IoT Hub devices, and you can see the menu for IoT stuff. And then what we need to do is right click, for example, on module.json, and then after adding the extensions, you will see that I can build IoT Edge module image and build and push IoT Edge module image. So if I can click here, I will have this, and then I need to point to the right folder that contains my image. So I'll choose AMD64, and it will start publishing this IoT Edge module. So now we will learn how to publish an Azure Stream Analytics job as an IoT Edge module on our IoT Edge that we've already created, and we will need to create few stuff also from the portal. If you're not familiar with Azure Stream Analytics, I recommend you to go through the official documentation from Microsoft and learn more about Azure Stream Analytics in an easy way. Azure Stream Analytics is a cloud component that can create and let you have real-time data processing or data analytics, sorry, for either IoT solutions or non-IoT solutions. So it will receive the data, we can have our analytics on it, we can have routing on our Stream Analytics job in order to get what we need from that data. So let's start by, so our goal is to publish or deploy an Azure Stream Analytics job on the IoT Edge. So in order to do that, we will need a storage account before going and creating the Azure Stream Analytics. So I will go into create a resource, I will go into storage, and I will choose a storage account, blob, file, table, or queue. I will click on it, and then I will need to create a storage account. I need to choose this subscription, and please make sure it's the same subscription as the subscription you created in the IoT Hub to avoid problems at this stage. The resource group, it's also preferred to have the same resource group. And then storage account name, I will name it course storage. For the location, it is already taken, so course storage. Okay, I will choose another name, so my course storage, it's good. For the location, I will choose the same location I created my IoT Hub in, which is West US. For the performance, I choose standard, account kind, and I won't choose these parameters. And then I will click on next to see what's on the advanced. So it's for the security, also on the tags. I don't need them for this moment. And then I will review and create my storage, which is here. And these are the options that I've chosen, and then click create, and we will wait for our notification to tell us that it has been created and deployed into our resource group. So there you go, we have our storage account, and then we can move forward now to the other parts like creating Azure Stream Analytics job, and we will publish it and deploy it into our IoT Edge as a module. And there you go, we have our resource created, deployment succeeded. We can go to the resource. It's now deployed into the resource group that I chose, which is 90 seconds. I have all the details here for my storage account. We have the events, access keys, configuration, encryptions, and we will go forward with it. Now that we have created our storage account, we will move forward and create our first Azure Stream Analytics job from the portal. So I will click on Create Resource. I can go into Internet of Things, and then I will look for Azure Stream Analytics, and I can see here Stream Analytics job. I can choose it, and I will be able to create a new Azure Stream Analytics job. So I need to give my job a name, so I will name it my course job. Hopefully it's okay. And for the subscription, I will choose my subscription. As we spoke in the last videos, it should be the same subscription as the IoT Hub and the storage account that were created in. So later on the resource group, I will choose the same resource group, and I will choose the location to be in the same location, which is West US. And for the hosting environment, we can see here two options, cloud and edge. As we spoke earlier, and you remember in the past videos, intelligence on the edge and intelligence on the cloud, and how we can have the stream analytics job created as a PaaS component on the cloud, or deployed as we will do now on the edge as an IoT Edge module. So here we will choose edge, and I will click create. It will take a few seconds to validate it, and now it's created into my subscription. let's wait for the same notification telling us that it has been deployed into our resource group, and then we can move forward. We will just check the component, and then in the next video we will see how we can configure this Azure Stream Analytics job. Now it's created, so let's go to our resource, and this is our Azure Stream Analytics job, and let's check the menu. So it's similar to the menu that we have on IoT Hub, like activity log, access control, tags, logs that we saw to prevent deleting or the data, for example. And what we will use for Stream Analytics, it's this part. So job topology, we will work with inputs, with outputs, the queries that we need to use, storage account settings using the storage account that we created, and so on. Now we can go to inputs, so we can create a stream input. So I will click on inputs, and then I need to click on add stream input, and then choose Edge Hub, and I will have this window shown, and I need to put my input alias. So I will name it temperature. It's good. I will click save. I will leave the other parameters for the default ones, and then normally it's added input. Okay, now I can go to outputs and then click add, choose Edge Hub, and the output alias I will choose it as alert, and it's good, JSON, and I'll click save. I will leave this serialization format and the encoding to the default parameters. Normally I have the notification that I added my output, and we are good. Once we added the inputs and outputs, we can go back to the job topology menu. We can choose query, and we will have a default text shown here as we can see it, which is a query, select into from, and we will use this in order to have a route on our Azure Stream Analytics. And I will add here a small query, like I will add here, I will select reset as command, and it will be into your output alias we chose, which is, as I named it, alert, from the input alias I chose, which is temperature. Let's write it correctly, and I will do a timestamp by time created, so we can see, we can have this regroupment by time created, and I will do, sorry, a typing uppercase group by, I will choose tumbling window. I will have each for in seconds, each 30 seconds, and I will say having the average machine dot temperature is upper than 70, and that's our query. So we will be selecting the machines having the temperature more than 70 degrees each 30 seconds, sorry, and this query will be running on the Azure Stream Analytics, and I need to click save. Changes now, okay, save, and it's saving the changes, and we are good. So now we have an Azure Stream Analytics job. We did in inputs for job topology, we gave it a name as temperature. Outputs is alert, and we have our query here ready in order to function on the Azure Stream Analytics job.
Let's go back now to our Stream Analytics job. Go to Configure, click on Storage Account Settings, and then we need to map the storage account that we created in the past video to our Stream Analytics. So we can select a new storage account, or we can create it manually. So I will choose the one that we created, choose the subscription, and for this I need to add a container. So I will name it my course container, and if you have another container, it will be also possible to map the existing container to your Azure Stream Analytics job while adding the storage account. So now we have the notification that it's created. We are all set to continue. we can go back to our IoT Hub, go to IoT Edge, and click here on IoT Edge. Once the window is shown, I can go back to my device that we created already in the past videos. I can click on Set Modules in order to access my modules and in order to be able to add models. So here I can see that I have an Add button for the deployment models. I can click on Add and I can see that I can add an IoT Edge module, a Stream Analytics job, or a machine learning model. Let's go back to our IoT Edge and then click Add and go to, let's add an custom model. I will name it temp sensor. I will paste the image URI that we used in the past videos, which is a custom developed one for a temperature sensor. And there you go. I have now a first module added. It's running on my IoT Edge. Now I will be adding the Azure Stream Analytics one. So I need to click on Add, go Stream Analytics, choose the subscription, choose my Azure Stream Analytics job from the Edge job, and then click Save and wait for it until it's published on the IoT Edge, and we will receive a notification once it's saved and it's published on the IoT Edge as a model, but we still require a lot of work in order to deploy it. Now that we can see the Stream Analytics is available on the Edge, it's not deployed yet. So if I can click on it, I will see the available parameters that I have, like the name, the restart policy, the desired status, the models that I have now on my Stream Analytics job. We can go back to the Stream Analytics job, click on Next in order to move forward, and then we can specify our routings. And here we will paste these routes that we will use from telemetry to cloud, alerts to cloud, and alerts to reset and telemetry. And we need to change the module name with our Stream Analytics job name. So I will, what we called my course job. I need also to modify alerts to reset and this one also, and there's one more here, so I need to change this to my course job. Need to remove those brackets to not have any errors from our routes, and also here, so I should remove this module name and click OK. Then click on next, and the next one will be to review the deployment. So here we can see the template that we have, the routes that we already defined to our Azure Stream Analytics, and if we are ready, we can just click on submit, and it will help us to see that our Azure Stream Analytics now is submitted. If we go a little bit down, we will see that it's easily published, it's easily specified in deployment and running as an IoT Edge module, which is our Azure Stream Analytics job that we've already. Once this is done, we can go back and refresh the portal from our browser, and then we can go back to our IoT Hub in order to check what's happening exactly on the Edge side and the modules on the Edge side. So I will go and launch our IoT Hub and then go a bit down to IoT Edge. Once I'm on the IoT Edge, we can go to my device one that I've already created in the past videos. We can go to set modules and then go a little bit down, and we can see that my course job now is running and it's created. It has our routes, it has the image URI that we specified, and we have the module published, and we can see the data if we want to do that by a command line on the command prompt.